Lesson 2, Part C. Change of base, expand, and condense. This is going to get us prepared to solve equations. Now, a reminder, x is equal to the base raised to the y, so log base b of x is equal to y. Y is our exponent. Logarithms are exponents. Change of base. Now, change of base is a little less necessary these days because your calculators do it for you. But if all you have access to is a scientific calculator, you need to know the change of base law. Base, essentially, if I take a look at my calculator, I have a log, base 10, and a natural log button. But a base could be any number. A base could be absolutely any number. Infinite number of possibilities. You can't have an infinite number of buttons. So if you have a different base, such as log base 3 of 8, I would like to know what exponent I'm going to put on 3 to get the value of 8. Well, I only have log and natural log. I know it's going to be 1 point something. Why do I know 1 point something? Because 3 squared is 9. 3 to the first is 3. 8's in between. Well, I can use this change of base formula to convert. Log base 3 of 8 becomes log base 10 of 8 divided by log base 10 of 3. Essentially, the 3 stays downstairs, and I just use log. I would get the exact same thing if I did natural log of 8 divided by natural log of 3. So I can use either one of those buttons. So now I could pull this up, and I can say, great. I'm just going to do log base 10 of 8. Don't forget to close your parentheses, divided by log of 3. And that'll give me my answer. Now, I will tell you that there is an easier way that we're going to look at if you have a graphing calculator or you have access to Desmos. But there are going to be times where that's not possible for whatever reason, and you're going to need to know the change of base formula. Typically, you're going to round to 3 decimal places. So, change of base law. Try these 3. I've set them up here for you. I'll show you these 2. Log base 6 of 5.6 is log of 5.6 divided by log of 6. And you get 0.961. Try log base 2 of 23, log base 4 of 64, and log base 2 of 39. Pause the video and try them. Great, you did a good job. You did a great job if you got 4.524, 3, and 5.285. Now this is one that you can use if you ever forget, who goes on top, who goes on bottom, and you forget that the thing that's underneath stays on the bottom. That's okay. Log base 4 of 64 you should be able to do without a calculator. What exponent goes on 4 to get 64? It's 4 cubed. So now I have the answer so I can check myself if I need to. Okay? Great. Now, logarithmic laws. This is just based on what you already know from Algebra 1. Remember, when you multiply like bases, you add the exponents. When you divide like bases, you subtract the exponents. You raise a power to a power, you multiply. Okay, the power times log base b of n. The roots, and then the change of base formula. Now, we can use logarithmic laws to approximate things. If you gave me log base 3 of 4 and log base 3 of 5 and wanted me to approximate these guys, log base 3 of 4/5, well, this is the same thing. Okay, oops, let me get up here. I'm doing division. So I can change this from 4/5 to the log base 3 of 4 minus the log base 3 of 5. Log base 3 of 4 minus log base 3 of 5. Since I know I have an approximation for log base 3 of 4 and log base 3 of 5, I can do 1.262 minus 1.465 and get negative 2.03. What I have to do is I have to look at log base 3 of 20. How can I rewrite this so that I use 4 and 5? Well, I can do that as log base 3 of 4 times 5, right? And if I look up here, log base 3 of 4 times 5 becomes log base 3 of 4 plus log base 3 of 5. So log base 3 of 4 plus log base 3 of 5. Now I'm going to add 1.262 to 1.465, and I find my answer is 2.727. Now 16. How about, 4 squared, right? We can do log base 3 of 4 squared. Then if I look up here, I'm going to use this powers. This power says this p is going to come down in front, so I'm going to get 2 times log base 3 of 4. Do I know what log base 3 of 4 is? I certainly do. And I'm just going to multiply it by 2, and I'll get 2.524. So you're just using some substitution. Here's your logarithmic powers. Here are 2 problems. Here's log base 5 of 3 and log base 5 of 6. Pause the video and try these 2. Okay, did you get 0.43 and 1.796? Okay. Remember that 2, how can I get 2? I can do 6 divided by 3. How can I get 18? 3 times 6. So I'd be using these top 2. All right, that's using the laws to do some approximation. Let's look at it in a little more depth. There are times when you want to expand or contract in order to solve. Those first 2 examples, or those previous 5 examples, were expanding so we could solve. They're the times where we want to condense, but you've got to be able to go both ways. So here to the right are your rules, your logarithmic laws. If I want to expand log base 4 of x squared divided by 3y cubed, first thing I'm going to do is use the quotient property. I have the x squared over the 3y cubed. So I'm going to use the quotient property, which is right here. I'm going to take the top and the bottom and make subtraction. Now, I have an exponent. But I also have multiplication here. Well, I can use my product property. X times y, and I can separate it so that it's addition. So I do that. But now notice I put parentheses in because I'm still subtracting this whole thing. Now I'm going to use the power. I'm going to use the power property here. So I'm going to bring the 2 down in front, and I'm going to use it here where I'm going to bring the 3 down in front. Notice that I continue to use the parentheses. Simplifying just means I'm going to take this minus and I'm going to distribute it. I have now completely expanded this so that each expression is as simple as possible. I'm taking a single log and then doing something else with it. Okay? All right. Try expanding this one. Pause the video and use the previous one as an example. All right, you're back. First, took the 9x cubed and the 2y squared, separated it. Then I went ahead and I separated out the 9 and the x cubed, and I'm subtracting this guy, separated it into log base 2 of 6, log base 6 of y squared. Now I'm going to bring down powers. The 3 comes down in front and the 2 comes down in front, and then I'm going to simplify by distributing the minus. Were you able to expand? Expansion follows pretty much those same 3 steps, unless the step doesn't exist. Then you don't worry about it. And for the most part, we're actually going to be condensing instead of expanding, meaning putting things together. So it's going to work the same kind of way, but in reverse. And remember, we go left to right. So log base 3, or log of 3 plus 3 log of 2 minus log of 6. First thing, I've got to put this together. So I'm going to get log of 2 cubed. Now I'm moving left to right, so 3 times 2 is log of 3 times 2 cubed. Then I've got the minus 6. That goes down here in division. Now, because everything is numbers, I can do 3 times 8 is 24. 24 divided by 6 is 4. Log base 4. Or log base 4, sorry, log of 4. It's log base 10. Okay, so again, you're just putting things together. You always look to see if you've got a power property, then the product, and then the quotient. It's just reverse. Pause the video and try this one. Okay, did you notice that I've got to take the 4 and put it as an exponent on the x, and 3, put it over here on the y? Now I've got subtraction. What do we do when we subtract? We divide. See? Now, pause this. There's some practice that's specifically on condensing and expanding that I would suggest you might try before you move on to solving. Okay?